Okay, welcome back to differentiation. This is the product rule now. So these questions are all going to be on the product rule. This question looks a bit beastly because we've got lots of roots and pies and things like that. I suppose that the work is quite long in that sense, so bear with me on this one, but the differentiation itself isn't that bad. It's just sort of messy algebra probably. So you're given the curve with this equation, and it says find the equation of the tangent to the curve at this point and write it in this form. So as we did before, we're going to look at the product rule, which says if we have a product of two functions, let's call them u and v, the product rule says when we differentiate, we can leave one of them alone and differentiate the other and multiply, plus leave the other one alone, differentiate the other and multiply. So there is your product rule. So in order to do this, we need to then define one of these as a u and one is our v. So let's say u is x squared, and then we're multiplying that x squared by cos of x squared. Okay, so again, in order to apply the product rule, we need to differentiate both of those. So du dx is 2x, and dv dx. And this actually involves the chain rule as well. So if we were just differentiating cos, we would get minus sine, and it would be minus sine of x squared. But we also need to then differentiate what's inside the bracket and multiply that, and that would be 2x. So that's chain and product. That's really common to happen, by the way. Okay, so those would be our results, and then to find dy dx, we'll just apply the rule up here. So it doesn't matter which order you do this, by the way. So say I do u times dv dx, that gives me minus 2x cubed sine x squared, plus v times du dx, which would be 2x cos of x squared. So again, this is our gradient function, and we want to look at what's the gradient at the point P. So at the point P, x is root pi over 2. So dy dx would be minus 2, and this is where the algebra gets a little bit messy. Root pi cubed is going to be pi times root pi, and over 2 cubed would be 8, and that would be sine of a quarter pi. So root pi over 2 squared would be pi over 4, plus 2 times root pi over 2 is root pi, cos again pi over 4. Okay, so that would be what you get as a specific gradient. I'm just going to simplify it a little bit. So I'm going to get minus a quarter pi root pi, and sine of pi over 4 is root 2 over 2, plus root pi, cos of pi over 4 is also root 2 over 2. So finally I get minus pi root 2 pi over 8 plus root 2 pi over 2. Right, let's just take a breather because we're about halfway through the question. So the hard work's done, which is the differentiation. Now we've just got to find the equation of the tangent. I'm just going to go through the algebra of doing this so you get the final result, but it is a little bit long. Okay, so the equation of the tangent then, we're going to do how we've done it before. So the equation of a straight line, and we're going to whack in the x and y coordinates and the gradient. And the reason that this is quite messy is because of that gradient that we get is not very nice, really. So we would get y minus the y coordinate is pi root 2 over 8 equals, and the gradient that we found, which is this, and that's going to be times x minus the x coordinate, which is root pi over 2. So all we've got to do now is try and simplify all of that. So I'll just run through some of the work. I won't write it all down. I'll let you kind of work through it yourselves and just make sure you check your algebra. So that's what we get there. On the right hand side, so multiplying this out, we should get minus pi root 2 pi over 8 times x plus root 2 pi over 2x plus, here we go, we're going to get pi times root pi times root 2 pi over 16 minus root pi root 2 pi over 4. Okay, so that's the multiplying out. Alright, just working through the algebra there, probably the easiest thing to do, since we've got lots of fractions, is multiply through by 8. And the reason why I want to multiply through by 8 as well is because, well, most of these things would actually be a bit neater when we multiply by 8. I would get 8y minus pi root 2 is this, plus this, and then we would get all of this over 2 when multiplied by 8, and then we would get this. Okay. Just from collecting together like terms, so things with x's in them. I think I missed an x somewhere. That's there. Things with x's in them, and y's, and then all of the constants as well. Pulling all of that together, we would end up with something like this: root 2 pi x plus pi root 2 pi over 2 minus 1, and then if I just pull everything to one side, I would get this. I pull it all to the other side. I could just get that, and that's the form that they want it in. Sorry, that was a bit long. I said it was a bit long, but make sure that you can work the algebra properly for that one. Let's move on to the next question though. So the next one is not nearly as bad, so we'll do this quite quickly. Again, it's a product, and if I say that that's u and that's v, I'll write them down, and you'll notice that we need to do the chain rule again for v. du dx is quite straightforward. dv dx is a chain rule, and the chain rule would say multiply that by the derivative of the bracket, which would be this, and that would give us that. So that's your dv dx. The product rule says multiply them together. It doesn't say multiply them together. It says u times dv dx, which is that, plus v times du dx, which would be this. Now, if we look back at the question, it says it wants it in this form. So it wants you to leave the bracket 5x minus 3 to the power of something, and we've got those here. It looks like we're going to have to factor out that, and I think we could factor out to the power 2, because we've got power 2 and power 3, and then kind of tidy up the rest of the algebra. So that's what it's asking you to do. Let's see how it turns out. First, we'll just simplify this a little bit. Which would be this, and then I could factor that out. If I factor it out, I would get, so I'll factor out this. I would get 45x squared plus 6 times one of them. Okay, so you see how this is the same as the line above. All I need to do now is tidy up the square bracket. If I multiply out this, I would then get 45x squared plus 30x squared minus 18x. And then tidy that up. I would get 75x squared minus 18x. And finally, writing it as they want it up here, ax times the bracket plus times bx plus c, I could pull out an x. I could also pull out a factor of 3, and that would leave me with 25x minus 6, and that's now in the form that they wanted. Right, we'll make this the last question then. I'll do this quite quickly. So we've got this as our equation. It says find d by dx using the product rule, and then find the gradient when x is 2. So let's say this is u, and this is v. Du dx is going to be this, and that's chain rule again, by the way, and then this is going to be this. As a rule, if you have e to the power of a function, differentiating, you can differentiate the power and then multiply it by the original function. So this is the rule we're using for that over here. Okay, using the product rule, let's do let's do u times dv dx, which would be this, plus v times du dx, which would be this. And what we can do is similar to the last question, is pull out a common factor, and I can see a common factor of e to the power of 3x, and I can also see a common factor of x plus 3. That would leave me with 3 times x plus 3 plus 2. And then if I simplify what's there, I would get this 3x plus 11. Okay, very quickly, part B, we'll just sub in x is 2. So when x is 2, dy dx then would be e to the power of 3 times 2, 2 plus 3, 3 times 2 plus 11, which comes out to be 5e to the power of 6 times 17, which is finally 85e to the power of 6. So that is the answer for the gradient. Okay, that's the product rule.